Welcome back to our discussions on triangles. Fifth question is, in the figure, DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. What is given in the question is, with reference to the figure, DE is parallel to OQ and DF is parallel to OR. To prove that EF is parallel to QR, first consider the triangle POQ. Given that DE is parallel to OQ, applying basic proportionality theorem, P upon EQ is equal to PD upon DO. Consider this as equation 1. Also consider the triangle POR. Given that DF is parallel to OR, applying basic proportionality theorem, PF upon FR is equal to PD upon DO. Consider this as equation 2. Compare equations 1 and 2. Two things which are equal to the same thing are equal to one another. By axiom 1, P upon EQ is equal to PF upon FR. Therefore, by the converse of Thales theorem, EF is parallel to QR. Hence the proof. Sixth question is, in the figure, A, B and C are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Show that BC is parallel to QR. What is given is, AB is parallel to PQ and AC is parallel to PR. To prove that BC is parallel to QR, this is again based on the converse of Thales theorem. First consider the triangle POQ. Given that AB is parallel to PQ, by applying Thales theorem, OB upon BQ is equal to OA upon AP. Consider this as equation 1. Again consider the triangle POR. Given that AC is parallel to PR, applying Thales theorem, OC upon CR is equal to OA upon AP. Consider this as equation 2. Compare equations 1 and 2. Two things which are equal to the same thing are equal to one another. Therefore, by axiom 1, OB upon BQ is equal to OC upon CR. By the converse of Thales theorem, BC is parallel to QR. Hence the proof. Seventh question is, using theorem 2.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Recall that you have proved it in class 9 as converse of midpoint theorem. And theorem 2.1 is Thales theorem. Well, what is given in the statement is, a line drawn through the midpoint of one side of a triangle parallel to another side. So consider a triangle ABC in which a line DE is drawn through the midpoint of AB through D parallel to BC. What is to be proved is, it bisects the third side. That is, the line DE bisects AC, or AE is equal to EC. That is, E is the midpoint of AC. Consider triangle ABC in which DE is parallel to BC. By Thales theorem, AD upon DB is equal to AE upon EC. Since D is the midpoint of AB, replacing DB as AD upon AD is equal to AE upon EC. By simplifying, AD gets cancelled. 1 is equal to AE upon EC. Therefore, AE is equal to EC. Implies that E is the midpoint of AE, or DE bisects the third side AC. Eighth question is, using theorem 2.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. Recall that you have done it in class 9 as midpoint theorem. Theorem 2.2 is converse of Thales theorem. What is given in the question is the line joining the midpoints of any two sides of a triangle. So consider a triangle ABC in which a line DE is drawn through the midpoint of AB and AC through D and E. What is to be proved is it is parallel to the third side. That is, DE is parallel to the third side BC. In triangle ABC, the ratio AD upon DB could be written as AD upon AD, replacing DB as AD since D is the midpoint of AB. By simplifying, it is equal to 1. Consider this as equation 1. Similarly, the ratio AE upon EC could be written as AE upon AE, replacing EC as AE since E is the midpoint of AC. By simplifying, it is equal to 1. Consider this as equation 2. Compare equations 1 and 2. Two things which are equal to the same thing are equal to one another. By axiom 1, AD upon DB is equal to AE upon EC. Therefore, by the converse of Thales theorem, DE is parallel to BC. Ninth question is, ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that the ratio AO upon BO is equal to CO upon DO. What is given in the question is, ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. So consider a trapezium ABCD in which AB is parallel to DC. Let its diagonals AC and DB intersect at the point O. To prove that the ratio AO upon BO is equal to CO upon DO. Construction. Draw EO parallel to AB. Now consider the triangle ADB. EO is parallel to AB. By applying BPT, we obtain AE upon ED is equal to BO upon DO. Consider this as equation 1. Now consider the triangle ADC. EO is parallel to AB by construction, but given that AB is parallel to DC, therefore EO is parallel to DC. By applying BPT, AE upon ED is equal to AO upon CO. Consider this as equation 2. Compare equations 1 and 2. Two things which are equal to the same thing are equal to one another. Therefore, by axiom 1, AO upon CO is equal to BO upon DO. By cross multiplying and transposing BO to left hand side and CO to right hand side, we obtain AO upon BO is equal to CO upon DO. 10th question is, the diagonals of a quadrilateral ABCD intersect each other at the point O such that AO upon BO is equal to CO upon DO. Show that ABCD is a trapezium. What is given in the question is, the diagonals of a quadrilateral ABCD intersect each other at the point O such that AO upon BO is equal to CO upon DO. Consider a quadrilateral ABCD. Let the diagonals AC and DB intersect at the point O. What is to be proved is ABCD is a trapezium. A trapezium has one pair of opposite sides parallel. So, AB parallel to DC is to be proved. Construction. Draw EO parallel to DC. Now consider the triangle ADC in which EO is parallel to DC. By BPT, AO upon CO is equal to AE upon ED. Consider this as equation 1. But given that AO upon BO is equal to CO upon DO, by cross multiplying AO upon CO is equal to BO upon DO. Consider this as equation 2. Compare equations 1 and 2. Two things which are equal to the same thing are equal to one another. By axiom 1, AE upon ED is equal to BO upon DO. By the converse of basic proportionality theorem, EO is parallel to AB, but EO is parallel to DC by construction, which implies that AB is parallel to DC. Therefore, ABCD is a trapezium.